Hello all, welcome back to my channel Roshni's EduNits. You can check out my channel for more videos related to the education in a different stream. Yes, today's topic is that clock domain crossing techniques part 2. Part 1 already it will be in my channel. You can go out and check there for the part 1, and this is for the topic of part 2. So in part one, I have covered different topics like introduction of clock. That means what is a clock and what are the types of clocks we have. Next, introduction on CDC. That means what is meant by CDC and what is the definition of CDC. Everything was done in the part one. Next, inputs of CDC. What are the issues we are going to see in CDC and what is metastability condition. So these are the parts which are covered. These are the topics which are covered in the part one. So if you need, you can go and check out the video for the part 1. It will be available in the channel. So first I told you the metastability. So what is metastability? Metastability in the sense when we send a data or a signal from one clock to the another clock domain, from one clock domain to another clock domain, when we send that too with a different clock, that means that too with the asynchronous clock, if we send, if the flops didn't meet a timing related one, in that cases the flop gives a timing violation. So when the flop gives a timing violation, will the data, we have a chance to get the data in a metastability condition. What is a metastability condition? Metastability condition is nothing but if the data output, it will not be completely zero, or either it will not be completely to 1. It will either to be 0, it will be either to 1, it will be in a mid of the state, but it will not completely to 0, completely to 1, it will be in some unpredictable state. So that case is said to be as an a metastability. So due to this metastability, there is a chance of losing a data, there is a chance of getting a data coherence and all. So how to avoid a metastability? See, we cannot avoid metastability completely, we cannot avoid, but we can neutralize. Whatever the flop we take, we'll be having a chance of getting metastability if it is a asynchronous clock. So we cannot permanently avoid a metastability, but we can neutralize the metastability. How can we neutralize? We can neutralize them by using some synchronizers. So first, getting into depth of the topic, let me explain you what is meant by synchronizer. So mainly the synchronizers are used to avoid metastability, nothing but to sample a data. So mainly we use synchronizer to sample a data and also to avoid a metastability. So if anyone asks you like what are the synchronizers, how can you give a definition? It's nothing but it is a digital circuit which is used to convert asynchronous signal from different clock domain to the receiver clock domain, which could not cause any metastability issue. So those type of circuits are said to be a synchronizer. That means it is a small digital circuit. What this digital circuit does, it will sample the data when we send this asynchronous signal from one domain to another domain. What it does, it will sample the data to avoid the metastability condition. So those type of circuits are said to be a synchronizers. So I told you first itself, we cannot avoid metastability completely, but we can neutralize, we have a chance to neutralize the metastability. So what are the scenarios of synchronizer? That means in the which scenarios can be used? See, we should calculate the missed sample when it is passed from the domain. See, from when the asynchronous clock or when the signal pass from one domain to the another domain, there is a chance of getting metastability, I told you. So if there is a chance of getting metastability, mean there is a chance of losing the data also, or there is a chance of losing the sample also. So what the synchronizer do, it is mainly used to calculate the to sample the missed data, and also to for whatever the data or whatever the signal which is passed from the domain, it should be sampled. So that are the main scenarios of the synchronizer. What are the main? Missed sample should be calculated and synchronized, as well as what are the signal or what are the data, whichever it is passed in the clock domains, it must be simplified or sampled. So these are the main functions of synchronizers. So we are having different types of synchronizers. So what are those? Two flop synchronizers, muck synchronizers, pulse synchronizer, handshake synchronizer. So what is a two flop synchronizer? See, here we will be having a flop, and here we will be having a source flop, and here we will be having a two flops, and this two flop is considered as a one cell, and this is the cell called synchronizer. So what is this? This is the first flop work with clock A, and last two flop work with clock B. This is a different clock, and this is a different clock. Different clock and different phase means what we can say? We can say it is an asynchronous clock. So it is working in a asynchronous clock. So whenever the data, but why do we use it for two flop synchronizer? Only for single bit data. To pass single bit data, we will be using two flop synchronizers. So whenever the data is passed, whenever the data is launched from the first flop, and the data should be received from the clock B. But how the data we get is that we will be getting a data in a metastability condition. Here, if you see the arrow mark, you can cleanly observe it is not completely either to 1, not completely either to 0. It is in some unpredictable state. So when we use a synchronizer, when we use another flop, so in that cases, with one clock pulse delay, we'll be getting a data which is of neutralized metastability condition. That means here we are not having in metastability condition, and the value is for 1. So what it does is that here we are using one flop, where we are using two flops as a synchronizers. So what, when a data is passed from first flop, input is passed from first flop, and that the input is received in the first flop output, that output how we get in the state of some metastability condition, and that output is again passed with the another flop. In another flop, what it does, we get again output with a delay of one clock pulse delay. So again that one clock pulse delay output will be there, no? That output should be given as input to the third flop. So when we give that input as a third flop, we get a perfect output without any metastability condition, with the two clock pulse delay. So how can we say that we get only either for two clock pulse or one clock pulse delay? We'll be checking data is checked for every 3 pulses of clock cycle. In that cases only we can say the data acquired was very correct without any metastability condition. So this is the working of two flop synchronizer. So what is the working of two flop synchronizer? Two flop synchronizer is nothing but first the data is passed, and the output is again sent to the second flop input, and again we will be getting an output with one clock pulse delay, and that output is sent as an input to the third flop, and we receive an output with a clean output without any metastability condition. So that state is said to be as a two flop synchronizer. So this is the main use of two flop synchronizer. Next is a mux synchronizer. Mux synchronizer is nothing but it is mainly used or worked with based on the mux. Here mux mainly works with an enable signal, as we know when we go for the digital topics. Here whenever we give an enable is a 1. See, here we are having a mux, right? Whenever if we give an enable is 1, the output doesn't change. Whatever the input we give, the output doesn't change. We get like that. But whenever we give the enable signal as 0, the output changes. Why? Because the output is connected to a destination flop of a input. So whatever the output we are getting to the mux, that is connected to the destination flop of a signal, hence the output may changes. So mainly, how can you say, can you explain regarding mux synchronizer? Mux synchronizer mainly works on an enable signal. So whenever the enable signal is high, that means whenever the enable signal is 1, the output doesn't change, it remains same. Whenever the enable signal is 0, the output changes because the output is connected to a destination flop of a input. In that cases, the output changes. So this is the mux synchronizer. Mux synchronizer is nothing but mainly it works with the enable signal.